Hey guys, Adam with FANUC here. Today we're going to cover a quick and fun little simple topic, but it's pretty common. It's the topic of timers. It's how to use the program timers in your TP code. So let's dive right into it, guys, and learn something new today. So here's a very simple program I've set up. Program name is fun. I'm working in the world frame, user frame 0's world. It happens that I've got my robot pointer tool set up as utool 2. I've taken time to set up my payload. I'm going to start this robot at a nice, safe, slow override of 10%, largely in part to I want to show the effect it has on our system timer, but also because you should always start slow and safe in real life. Lessons learned, kids. So the robot's going to start at this home position. Then we're going to do the 2-step, and we're going to go 2, 3, 4, 5, and back to 2, run around this table, and back to home. So let's go ahead and think about where we want to start and stop the program timers. Okay, with FANUC, you have to sequentially tell it when you want to start and stop. Just like in PLC world, there's always conditions of when you start and when you stop. Here, it just happens in sequential order. So I'm going to say right here, I'm starting at home. Right before I get to doing my work, let's start my timer. Instructions. Down under miscellaneous, you will see timer. When I click on timer, it gives me a open bracket asking what timer number I want to work with. By default, your robot should come with 20 timers in available memory. You can, of course, expand upon that if you want, but anywhere from 1 to 20 is fine. I'm going to say timer number 1 for this one because I haven't used any yet. Timer number 1, what do I want to do? I can start, stop, reset, and then there's some other. Keep in mind that FANUC timers are retentive, okay? Meaning that if I continually start and stop a timer, it'll keep building upon itself until I issue it a reset to go back down to 0, just like your old school stopwatches in gym class. It'll start and stop and keep adding until you issue the reset. That's retentive. So I'm going to set this command that says timer number 1 to start. And at the very end of my code, after it runs around the table and makes its way back home, we'll go ahead and say miscellaneous timer number 1 stop. So you can see that I have started my timer, I'm doing my work, I've stopped my timer. Yippee! What else? We need to output that data. We need to do something with it. In this example, I'm just simply going to push it into a register. That register maybe goes to your PLC or goes to an HMI, whatever it may be, a process logger. Let's go ahead and do something. I'm going to define register 1 is cycle timer. And I'm going to add another instruction, add register, and say register equals. I want to choose register number 1. You see register 1, cycle timer equals, what does it equal? It is going to equal timer. What timer is it going to equal? It's going to equal timer 1. So at this point in the code, the timer has started and then stopped, so it's no longer counting. So I've got a stopped timer. So this will be the accumulated value. This will be the number that's in there. It's pushed into R1. And then let's go ahead and hit that reset button on it. Timer number 1, reset. That way it goes back to 0 for future use. So there's a good look at my code. Let's go ahead and test that. And make sure that this guy's ready to go. Play. Wonderful. So here goes Mr. Robot. Nice and safe and smooth, laying that good beat around the table. Looking great. And so we can actually also, by the way, monitor in our system variables the timer as it's incrementing. But in this one, we'll only see at line 16 when it dumps that data into here. 36 seconds to go around the table. And yes, if you were watching my YouTube clock timer, you're saying that wasn't 36 seconds. That's because RoboGuide speeds it up so you're not sitting here all day. If we wanted to fact check our timer here, I can go down to my profiler data. If you've not watched my video on profiler data, please watch it. It's super, super useful. And you will see that, yes, indeed, this robot ran for 36 seconds. The decimal place difference that you see, we can look here and see that I didn't start my timer until line 7, but 1/3 of a second of code was executed before we got there. So that's why you see my profiler data says 36.6. This is telling me 36.3. It's because I didn't count that first third. Anyway, I digress. Pedantics here. The fact is the timer's working. Now, let's speed this bad boy up. Let's put some horsepower under the hood. Let's let it eat. And let's see what this timer does for us. Run. Now we're making money. So this robot just ran that cycle at 3.8 seconds, scooting right along. So that's very useful information. I'm going to add one more fun little bonus on here. Sometimes people like to compare cycles one after another, gathering data over the course of a series of parts or a pallet or even a shift. Let me show you a little bit of what that looks like. Let's say I wanted to run this robot. I'm going to only do 3 cycles for this video to keep life good. But let's say you wanted to log cycles for a while. Let's say cycle 1, cycle 2, and cycle 3. And of course, that could be as many as you want. Now let me make this robot run 3 cycles by way of adding a for loop. So I'll say for, and then I need a register for my counter. Maybe we'll use R10, doesn't really matter. And I'm going to have register 10 count from 1 to 3. That'll be 3 cycles. Let's be a good boy. Comment your code. And at the end, of course, I need my end for. So now you can see that my code is going to run this loop 3 different times. And I want to log the cycle speed for each time it loops. All I'm going to do is right here, where we are writing the timer value, I'll just indirect address that. I'll just make that be R10, a register of a register. Because as R10 is doing its job, it's going to count 1, 2, 3. This will be R1, R2, R3. And the timer data should populate R1, R2, R3. And we'll see how this robot runs as it's cruising along. Let's test this bad boy out at the full Monty 100% and see how she plays. Cycle 1, see that update. Cycle 2, see that update. And cycle 3, see that update. So, shouldn't surprise you, doesn't surprise me that every single cycle is identical. It's because everything is the same and identical. But, let's say, your project has some sensors or some conditions or some vision inspection or something like that. It'd be worth, looking at your cycle time. So, hey guys, I really hope that helps. Use it. Let me know how you like it in the comments. Let me know if you have questions, topics for future videos. Please like and subscribe. You know the drill. It helps. And as always, have fun coding.